So in this tutorial on quadratic equations, we want to look at completing the square. But before we look at questions from the tutorial, we want to look at one or two basics on this topic. We know that any quadratic equation can be written in the form y equals ax squared plus bx plus c. And this is known as standard quadratic form. This equation can also be written in a different form as y equals a into x minus p all squared plus q. And this is known as completed square form. Now the graph of a quadratic equation is known as a parabola. And when a is greater than 0 or positive, the graph smiles like a positive person. When a is less than 0 or negative, the graph frowns like a negative person. In both cases, the coordinates of the vertex or turning point of the graph will be P and Q. So let's look at the first question in this tutorial. It says, for each of A, B, and C below, state whether the graph that represents the equation have a maximum or a minimum value. Then secondly, write down the coordinates of the vertex or turning point. And thirdly, draw the graph on the axis provided. Show only the coordinates of the vertex on the graph. So in A here, we have this equation. Now, you should note that this equation is in the form y equals a into x minus p all squared plus q. So the equation is in completed square form. And in number 1, we have to state whether the graph has a maximum or a minimum value. How do we do that? We look at the value of a. In this case, a is equal to 2. Now, we can see that a is positive. So when a is positive, we know that the graph smiles like a positive person, and we have a minimum value. So then the answer to the first question here, the graph will have a minimum value. Then in a second question, we have to write down the coordinates of the vertex or turning point. So these coordinates here. We always get the x coordinate by taking whatever is inside the brackets here and making it 0. So x minus 3 will be 0. And we solve for x, and x is 3. So the x coordinate of the vertex or turning point will be 3. How do we get the y coordinate? The y coordinate will always be the value of q here. In this case, q is negative 4. So we know our y coordinate will be negative 4. So the coordinates of the vertex or turning point will be 3 and negative 4. Then in number 3, we have to draw the graph on the axis provided. And we only have to show the coordinates of the vertex. So let's do that. We know our coordinates are 3 and negative 4. So our x coordinate is 3 and our y coordinate is negative 4. So this will be the turning point of the graph. And we already know the shape of the graph. It has a minimum value, so we can draw it. So it's going to look something like this. Let's look at B. We're given this equation. Now, once again, this equation is in the form y equals a into x minus p all squared plus q. In other words, it's in completed square form. And we need to say whether the graph represented by this equation or the graph that represents this equation will have a maximum or minimum value. Now, we look at the value of a. A is 1 here. So there's a 1 in front of the brackets that we don't write. So positive 1. So we know a is positive 1. In other words, a is greater than 0 or positive. And the graph will smile like a positive person. And we'll have a minimum value. So the answer to number 1 here is that the graph has a minimum value. Then in number 2, we have to write down the vertex or the coordinates of the vertex. And to get the x-coordinate, we take what is inside the brackets. So x plus 1. We make it equal to 0 and we solve for x. So x will equal negative 1. Then to get the y-coordinate, we look at q. So q will give us the y-coordinate. In this case, q is negative 2. So we know our y-coordinate will equal negative 2. So the coordinates of the vertex will be negative 1 for x and negative 2 for y. Now we have to draw the graph on these axes. So we know our x-coordinate is negative 1. So negative 1. And our y-coordinate is negative 2. So negative 2, about here. And this will be the turning point. We also know the shape of the graph. It looks like this. And so we can draw it. So something like this. Let's look at C here. So we're given this equation. And once again, this equation is in completed square form. In other words, it's in the form y equals a into x minus p all squared plus q. So in the first question, we have to state whether the graph that represents this equation has a maximum or minimum value. And we look at the sign of a. So a in this case is negative 1. So there's a negative 1 here in front of the brackets that we don't write. So we know that a is negative 1. So a is less than 0 or negative. And if a is negative, the graph will frown. It will frown like a negative person. And we will have a maximum value. So then the answer to 1 here is that the graph will have a maximum value. Then we also have to find the coordinates of the vertex of the graph. To find the x-coordinate, we take what is inside the brackets, we make it equal to 0, and we solve. So we see that x comes to 2. Then the y-coordinate of the vertex will be given by q. In this case, q is positive 3. So it means our y-coordinate of the vertex will be positive 3. Now we can draw the graph showing only the coordinates of the vertex. So the coordinates of the vertex will be 2 and 3. So we want to draw the graph. So it's 2 for x and 3 for y. This will be the turning point or the vertex. And we know the shape of the graph looks like this. So we're able to draw the graph now. And it's going to look something like this. Then in question 2a, we have to solve this equation. You should note that this equation is in completed square form. In other words, it's in the form a into x minus p all squared plus q equals 0. So we have to solve this equation, which is in completed square form. Many students may be tempted to square out the brackets first, then add like terms, and then solve the resulting trinomial or quadratic. However, There's a much quicker way of doing it, of solving this equation. So instead of squaring out the left-hand side here, the brackets on the left-hand side, we're going to move the -4 to the right-hand side. So equals +4. We want to make x a subject of the formula. So to get rid of the square on the left-hand side, we take the square root on the right-hand side. However, important to note that whenever we take the square root on the right-hand side of an equation, we always need to write plus or minus. So x minus 3 is plus or minus the square root of 4, which is plus or minus 2. Now we can isolate x on the left-hand side, so we can make or move the -3 to the right-hand side. It becomes +3. And now we can write down our answers. X will equal 3 plus 2, which is 5. Or x equals 3 minus 2, which is 1. Then in question 2b, we have to solve this equation. Once again, this equation is in completed square form. So it's in the form a into x minus p all squared plus q equals 0. So instead of squaring out the brackets and adding like terms and then solving the equation as a trinomial or a quadratic, we're going to keep the brackets and we're going to move the -5 to the right-hand side. So it becomes +5. We want to make x a subject of the formula. So to get rid of the square on the left-hand side, we can take the square root on the right-hand side. So it's going to be plus or minus the square root of 5. Now we can isolate x on the left-hand side by moving the 2 to the right-hand side. So -2 plus or minus the square root of 5. Now we can write down our two answers. X will equal -2 plus square root 5, or x will equal -2 minus square root 5. We can do these on a calculator. So -2 plus square root 5, and that is 0.236. 0.236, correct to 3 significant figures. Let's get the second answer. So -2 minus the square root of 5. And it comes to -4.24. So -4.24. Then in question 3, we have to write this expression in this form. Now the expression over here is in standard quadratic form. In other words, it's in the form ax squared plus bx plus c. And we have to write it in this form, which is completed square form. So let's have a look at how to do this. So we have 2x squared plus 12x minus 2. The first thing to note is that the x squared coefficient is 2 and it's not 1. When this is the case, we take out the 2 or the x squared coefficient as a common factor, but only from the first two terms here. So we're going to take out 2 as a common factor. 2 into 2x squared is x squared times. Then we have a plus. And 2 into 12x is 6x times. And we still have this -2 as well. So the next step is to take the x coefficient inside these brackets, which is 6, to multiply it by a half and to square the answer. So 6 times a half is 3, squared is 9. Now we're going to add and subtract the 9 inside these brackets. So we first add 9. So the order is important here. We first add 9 and then we subtract 9. Now, we're always going to end up with a perfect square inside the brackets. The first 3 terms inside these brackets will always be a perfect square. So we factorize it. The square root of the first term is x. Then we have a plus. And the square root of the third term inside these brackets will be 3. And this is all squared. We still have this negative 9 here. And we multiply the negative 9 here by the 2. So 2 times negative 9 is negative 18. Now we can simplify. Negative 18 minus 2 is negative 20. So we have written this expression in completed square form now. To find the values of a, b, and c, we compare our answer to this form. So comparing our answer here to this completed square form, we can see that a is equal to 2, b is equal to 3, and c is equal to 20. So in this question it says, this expression can be written in this form. So here we have a quadratic expression, and we can write it in completed square form, and then we need to find the values of p and q. The first step will be to rewrite this expression. We want to write it in the form ax squared plus bx plus c. So rewriting it in this form, we'll get negative 2x squared plus 12x plus 5. Now, the x squared coefficient is negative 2. It's not equal to 1. So our first step here is going to be to take out the negative 2 as a common factor from the first 2 terms. So negative 2 into the first term here, x squared remains. Then a minus times a minus will give us a plus. And then 2 into 12x, 6x times. Now we're going to take our x coefficient, negative 6. We're going to multiply it by a half, and we're going to square the answer. And this comes to 9. The 9 we're going to add and subtract inside the brackets. So the order will be important. We're first going to add the 9, and then we're going to subtract it. Now, the first 3 terms inside the brackets will be a perfect square. So we factorize it. We take the square root of the first term, which is x, this sign, which is a minus, and the square root of the third term inside the brackets. So 3, and this is all squared. We still have this negative 9 to deal with here. So we're going to say negative 2 times negative 9 is positive 18. And then 18 plus 5 will give us 23. Now we can compare what we have here to this completed square form. We need to find the values of p and q. So p is what's inside the square brackets here, or the brackets squared. However, here we have x plus p, and here we have x minus 3. Now, you should note that x plus p, so x plus p, is the same as x minus negative p. So x plus p is the same as x minus negative p. So from this here, we can see that negative p will equal 3. So negative p will equal 3. And that means that p is equal to negative 3. Let's now look at part B of question 4. It says write down the coordinates of the maximum point of this equation. The maximum point is the same as the vertex or the turning point. So we need to write down the coordinates of the vertex. Now in part A, we saw that we could write this quadratic expression in completed square form as 23 minus twice x minus 3 squared. So this is our completed square form. Now, to find the x-coordinate of the maximum point, we take what is inside the brackets and we make it equal to 0. And then we solve for x, and we see that x comes to 3. So this will be the x-coordinate of the turning point or maximum point. Then the y-coordinate will always be the value of q. In this case, it's 23. So in coordinate form, our coordinates will be 3 and 23. So in question 5a, we have to write this quadratic expression in completed square form. So it's x squared plus 10x plus 14. In this case, we don't have a common factor to take out from the first two terms. The x squared coefficient here is 1. So we're going to go to the next step, which is to take the x coefficient, in other words 10, to multiply it by a half and to square the answer. And this comes to 25. The 25 we're going to add and subtract to the expression here. We first write down the first two terms, so x squared plus 10x, and now we add and subtract 25. And of course we still have the positive 14 here. So plus 14. The first three terms here will be a perfect square. So we're going to factorize it. The square root of the first term is x. Then we have a plus. And the square root of the third term here is 5. So x plus 5 all squared. We still have the negative 25 plus 14 here. So negative 25 plus 14 is negative 11. So now we have written this quadratic expression in completed square form. Let's look at part B now. It says on the axis, sketch this graph or the graph of this equation, indicating the coordinates of the turning point. So how do we get the coordinates of the turning point? We look at this completed square form, and to get the x-coordinate, we take what is inside the brackets here. So x plus 5. We make it equal to 0, and we solve for x. So x is negative 5. Then the y-coordinate of the turning point will be negative 11 here. So y is equal to negative 11. Now, also to note that this equation has an x squared coefficient, which is positive. There's a plus 1 here that we don't write. And that tells us that the graph smiles like a positive person, and we have a minimum value. So let's draw the graph. The x is negative 5. Of course, this is a rough sketch. And the y is negative 11. So our turning point will be over here. And the graph will look something like this. so a parabola. So in this question, we have to write this quadratic equation in completed square form and then find the values of a and b. So we have y equals x squared plus 7x minus 5. The x squared coefficient here is 1. So there's no common factor to take out from the first two terms. We're going to go to the next step. We rewrite the first two terms. Now we're going to take the x coefficient, which is 7. So 7. We're going to multiply it by a half and square the answer. So this is 7 over 2 all squared, which is 49 over 4. We're going to add and subtract 49 over 4. And of course, we still have the negative 5. So minus 5. The first three terms here will be a perfect square. So we take the square root of the first term, which is x, this sign, which is a plus, and the square root of the third term, which is 7 over 2. And this is all squared. We still have minus 49 over 4 minus 5. We can add these terms, so we can do that on the side. So minus 49 over 4 minus 5. Now the 5 we can write as 20 over 4. And this comes to negative 69 over 4. So minus 69 over 4. Now we have written this equation in completed square form. And we still need to find the values of a and b. So we can compare our answer here to what we have in the question. We have x plus a all squared plus b. So that means a is 7 over 2 and b is negative 69 over 4. So a is 7 over 2 and b is negative 69 over 4. So in question 7, we are given this equation and we need to find the values of p and k. The left-hand side of this equation is of course in completed square form. What we're going to do is we're going to square out the left-hand side. So when we square out x minus 5, we're going to get x squared. So the first term squared, then the first term times the second term times 2. So x times negative 5, which is negative 5x, times 2, which is negative 10x. And in the second term, squared, so plus 25. Because negative 5 squared will give us positive 25. Then we still have plus k on the left-hand side. The x's squared will cancel on both sides. And we're left with negative 10x plus 25 plus k equals negative px minus 21. Now we use inspection. So we compare what we have on the left-hand side with what we have on the right-hand side. The coefficient of x on the left-hand side is negative 10. And on the right-hand side, it's negative p. The x coefficient on the left-hand side must equal the x coefficient on the right-hand side. So that means that negative p must equal negative 10, and therefore p is equal to 10. We also need to solve for k. So the constant on the left-hand side, in other words, the term or terms without x in it on the left-hand side, is 25 plus k. And on the right-hand side, the constant is negative 21. So the constant on the left-hand side must also equal the constant on the right-hand side. So 25 plus k must equal negative 21. And we can solve for k. we can take the 25 to the right-hand side. So negative 21 minus 25 will give us negative 46.